Okay students, so from this relation 2 into 2l plus 1 we can find out the maximum number of electrons in every orbital. For s orbital it is 2, p orbital 6. In the case of d orbital the value of l is 2. So here we can substitute 2 by substituting 2 2s are 4, 4 plus 1 5, 5 2s are 10. So in d orbital the maximum number of electrons will be 10. Then in f orbital the L value is 3. So here we can substitute 3. 2 3s are 6. 6 plus 1 7. Then 7 2s are 14. So in F orbital, maximum 14 electrons will be present in the orbital. And dear students, from this L value we can also find the angular momentum of any orbital. The angular momentum is equal to square root of L into L plus 1 into height divided by 2 pi. From this we can find out the angular momentum. So what are the informations we have got from this azimuthal quantum number? The first one is it is denoted by the symbol L. It is mainly used to represent the orbitals, subshells in every energy level. And L value 0 means S orbital, L value 1 means P orbital, L value 2 means D orbital, L value 3 means F orbital. And the maximum number of electrons in every orbital can be found by using the relation 2 into 2l plus 1. By substituting various values in L, we can get the maximum number of electrons in every subshell. Okay, and it is also useful for finding the angular momentum. Angular momentum is equal to square root of L into L plus 1 into height divided by 2 pi. Okay, with this azimuthal quantum number over, then we can discuss about the magnetic quantum number. Okay, that is the next concept we are going to see. What is called as magnetic quantum number and the informations about the magnetic quantum numbers we will see. Okay, magnetic quantum number. It is denoted by the symbol M and it is mainly used for the orientation of orbitals in space. Space orbitals eppadi orient aayirukku. So that we can form by using the magnetic quantum number, and that is the major application of magnetic quantum number. And this can be justified using Zeeman effect, the splitting of spectral lines in the magnetic field, so that we can study only through the magnetic quantum number. And for the given value of L, L over value ko M values are ranging from minus L to plus L. Okay, for a given value of L, the M value ranging from minus L to plus L. Okay, let us take the first one. L is equal to 0 means S orbital, but for 0 we cannot write minus 0 plus 0. We can skip that. Here including 0, we must take 0 also. Okay, then when L is equal to 1, the M values will be minus 1, then 0 plus 1. So we can say P orbital has 3 orientations, that is Px, Py and Pz. Okay, in P orbital we have 3 different orientations, that is Px, Py and Pz. L value 2 will be the value of M value will be minus 2, minus 1, 0, plus 1, plus 2. It has 5 orientations, that is P orbital, that we can write dxy, dyz, dzx, then dx square, y square, then dz square. These are the 5 orientations of d orbitals. So the orientations can be found by using the magnetic quantum number. Okay, and in the last one, in the azimuthal quantum number, we saw that the angular momentum can be found, no? And in this one, the orientation of angular momentum can be studied using the magnetic quantum number. Okay, the magnitude of angular momentum can be studied using the subsidiary quantum number, whereas the orientation of angular momentum can be studied using the magnetic quantum number. Okay, so the info we have got, the first one, it is denoted by the symbol M and it is mainly used for representing the orientation of orbitals. For a given value of L, M value ranging from minus L to plus L including 0. Some examples I have shown you. When L is equal to 1, M will be minus 1, 0, plus 1. When L is equal to 2, M will be minus 2, minus 1, 0, plus 1, plus 2. With this magnetic quantum number over, then finally we have spin quantum number. It is very easy. It is denoted by the symbol S. Okay, okay. Spin quantum numbers. Okay, spin. We know that every electron is spinning around the nucleus. Also, it is spinning by its own axis. Okay, அது nucleus சுத்தி வந்துட்டு தன்னதானேவும் சுத்திக்கிடுது. That we know. Okay, so spin quantum number. Then the spin of electron may be either in the clockwise direction or in the anti-clockwise direction. So based on that, every electron in a subshell. ஒரு subshell இருக்கிற எந்த ஒரு electron, two electrons will be there. So the spin of one electron will be plus half, whereas the spin of other electron will be minus half. So with this spin quantum number over, one electron will be rotating in the clockwise, whereas the other electron will be rotating in the anti-clockwise. So we can have the values of S as plus half and minus half. When the spin of electron is in the clockwise direction, we can use the term plus half. When the spin of electron is in the anti-clockwise direction, we can use the term minus half. Okay, Mama. So with this, the quantum numbers over. Principal quantum number now, it is used for telling us about the energy level or the shell in which the electron is present. Then azimuthal abdina, the subshells. Magnetic na, the orientation of orbitals. Whereas the last one, spin quantum number, is used to tell us about the spinning of electrons. There are two possible spinning. One is in the clockwise direction, whereas the other one is in the anti-clockwise direction. Those are plus half and minus half. Okay, Mama. With this quantum numbers over, go through the video and learn them. Thank you.